I am Dr. Kavitha, Professor, Department of Physics, Dr. MGR Educational and Research Institute. Today I am going to take the topic laser and its characteristics for third year basic physics. First, what is a laser? Laser is a light amplification by stimulated emission of radiation. That is, the light is getting amplified by stimulated emission. That is the process used here. And what is the difference between ordinary light and a laser beam? Let us see in this PPT. Ordinary light, the angular spread is more, whereas laser beam, the angular spread is less. The ordinary light are not directional. The laser beams are highly directional. It is less intense, whereas the laser beams are highly intense. The ordinary light is not a coherent beam and it is not in phase, whereas the laser beam is a coherent beam and is in phase. The light are polychromatic, whereas laser beam are monochromatic. Examples for ordinary light are sunlight, mercury vapor lamp. Laser beam examples are helium neon laser and carbon dioxide laser. And now coming back to laser, it's a device which emits a powerful monochromatic collimated beam of light. The emitted light waves are coherent in nature. Let us see the diagram for this laser. It has a flash tube. One end is fully reflecting and other end is partially reflecting. Now let us see the laser components. It is laser components, one is fully reflecting, as already told you, other end is partially reflecting. They are acting as the optical resonators. And these optical resonators, they reflect the laser beam through the active medium for amplification. The active medium means the medium in which the population inversion takes place. The active medium contains atoms which can emit light by stimulated emission. The excitation mechanism is a source of energy to excite the atoms to the proper energy state. Now comes population inversion. What is population inversion? If the number of atoms in the excited state is greater than the number of atoms in the ground state, then we call it as population inversion. That is, N2 should be greater than N1, where N1 is the number of atoms in the ground state and N2 is the number of atoms in the excited state. Let us see the characteristics of laser. First one is coherence, intensity, highly directionality, high monochromaticity. What is coherence? The wave trains which are identical in phase and direction are called coherent waves. High intensity. Due to coherent nature of laser, it has the ability to focus over a small area and hence intensity is very high. High directionality. The angular spread of laser beam is 1 mm per meter. Now comes high monochromaticity. It is monochromatic source. If it is having only one wavelength, we call it as monochromatic. If it is having more than one wavelength, it is called polychromatic. Here laser beam is highly monochromatic. The light from the normal monochromaticity source spread over a range of wavelength of the order of 100 nanometer, but the spread is of the order of 1 nanometer for laser. Yes, now comes the mechanism of laser. First one is absorption. Second one is spontaneous emission. Third one is stimulated emission. First we can see absorption. That is, the atom in the ground state, when it absorbs a photon of energy, it goes to the excited state. This is called absorption. Now comes spontaneous emission. Now the atom in the excited state, it won't stay there for a long time. So it comes spontaneously back to the ground state without any triggering source or triggering action. That is called spontaneous emission. Here when it is coming from the excited state to ground state, they emits a photon. of energy h nu. Stimulated emission. Stimulated, from the name itself we can understand what is it is happens only by some triggering force, that is stimulated. Okay, so here the atoms in the ground state absorbs a photon of energy and goes to the excited state. In the excited state also, it has to be triggered by some photons of energy, and so it comes to the ground state with the emission of 2 photons. Now, what is the difference between stimulated emission and spontaneous emission? Stimulated emission, it is not a random process, whereas spontaneous emission is a random process. The photon get multiplied through chain reaction in stimulated emission, whereas the photon do not get multiplied through chain reaction in spontaneous emission. It is a controllable process in stimulated emission, whereas it is not controllable process in spontaneous emission, and it is more intense and also monochromatic in stimulated emission, whereas it is less intense and polychromatic in spontaneous emission. Okay, thank you. If you are having any doubt, kindly ask me.